we have 2D graphics and we have 3D graphics. So it's kind of one dimensional up. So 2D graphics and 3D graphics. Okay, but in complexity there is no similarity. Means 3D graphics is means many times more difficult to 2D graphics. So that can be kind of experimental. So anyone can see how much the difference is between 2D graphics and 3D graphics. Now in 3D graphics there are library comes from Microsoft also, but we see mainly opengl library that comes for the 3D graphics. Now opengl is it's a game of vertices. So if I have kind of vertices, then I just think about the vertices and then we talk about the primitives. So it's a vertices belongs to a triangle, or vertices belongs to a line, or vertices belongs to a quad. So if I set vertices and I set the primitive, then remaining is what is the color of the vertices. Vertex position, its primitive, its coloring, and then transformation. So once we do the transformation, then vertex position changes. So after the transformation, now opengl rethinks about the vertices as per the primitive. Then it goes for the net to net the shape that it brings. Then it goes for rasterization. Means I have a triangle, and then it got rotated. Okay, so new vertices comes into the picture, but still it is a triangle. So if it is a triangle, then it goes for rasterization. Means it think about the pixel. Now, since I have set the coloring of the vertices, then what would be the pixel color? Okay, at the end, a pixel has the color, not the vertex. So vertex comes into the picture only for the transformation. So whatever the color we assign at vertices, so those colors would be kind of interpolated for the pixel. Okay, there are minhinc and forward modeling and so many things that comes when lighting comes into the picture. Whatever means we have to think about the pixel coloring. So in basic term, pixel coloring comes from the vertices. Vertex coloring we assign from the outside. So vertex coloring, vertex position, and then transformation. So and then primitive. So once transformation is done, based upon the primitive, rasterization happens. Once rasterization happens, then pixel color is interpolated from the vertices color. So that is the grammar of the opengl. Now, question comes is what about lighting? Okay, so based upon the lighting, like we talked about the minhinc or forward model, then we discard the vertex coloring because it is not required, and then we think about the lighting falling over the vertices, and based upon the lighting we think about the coloring at the vertices, and then interpolation at the pixel level. So then again with the lighting through the vertices we get the pixel color. So that is the concept. Okay, so at the end, either through vertices coloring pushed from external as extensive parameter, or through lighting, through interpolation we get the pixel color. Okay, so that is the concept. Okay, there is one more way then that we get the pixel color, that is texture. Okay, so rather than interpolating the vertex color into the pixel. Okay, now we get the pixel color. So 3 vertices, triangle, 1 point, 2 point. What are the color at the vertices? So those colors we interpolate at the rasterization, and then we think about the pixel color. But in texturing, we have full texture. So that texture color we set as pixel color. Okay, so opengl is not physics, opengl is not chemistry, and opengl is not biology. So opengl is pure mathematics. So mathematics, when it happens, it cannot work in kind of much analog fashion. It is digital and it is discrete. So when we think about the texture color to be set as pixel color in the kind of frame buffer, then what is the texture color for each pixel? So that comes into the picture. Now texture, that if you see the texture is another kind of set of textures. Okay, so texture is not kind of smooth or it's not analog. Okay, so it's not constant. It's not it doesn't vary in a constant fashion. There is no equation. So there are set of texture color. So each texture. So I have a quad, and on the quad I have texture. So quad has set of pixels. Texture has set of textures. Each texture has coloring. Now that color is getting mapped. Each texture would get mapped to a pixel. It looks the way it happens. It's a kind of logical. So every texture will get mapped to pixel, but it doesn't happen in the reality. Means texel density and pixel density comes into the picture. If texel density is less, then there will be magnification. And if texel density is more, then there will be minification. So more texel will be mapped to few pixels, or more texel would map to one pixel. In that case, taking the pixel as reference point, then we see minification, we do kind of averaging, that is linear, or we go for the nearest. So that is magnification and minification. Okay, one thing. Second thing is, if I have image, if I have a primitive, means quad is this big, but texture is this big one, then how small texture would go to all the kind of areas in the kind of primitive? So that is another big question. So one is clamping. Like if I have an image and this big board, I have to draw one image, then border it would clamp. Image in the middle and its border, it will clamp to the full kind of a stretching, or it would repeat. Okay, so why this much discussion happening? Because we see kind of lighting and we see texturing. So that was kind of texturing, lighting, and then various kind of shaders. Means opengl is straightforward. Means it's very simple if you think step by step. Otherwise, you cannot crack it. Means it's very difficult. Or it is very simple if you think step by step. So, what about shadowing? So, we have seen shadowing, like how we kind of generate the shadowing. So, if I have a kind of image, if I have an object and there is a light source falls on the object, then there will be shadow. Camera is this side. So, camera is looking at the object, light source is here. This side, shadow would form. Okay, so consider the case that, so I think in the tutorial we have seen that how we do the shadowing. So from the light source looking at the object, then we kind of we create a texture image. Okay, so considering the light source as camera and considering the object as kind of the real model, so we use a look at and those kind of utility, so that we bring the light at the kind of center and we do some kind of transformation in the rotation. So, but still, in that way, we kind of do a shadow texture, and that shadow texture in reality means one pass generate the shadow texture, and in the next pass from the real camera we draw the scenery and we take the shadow texture as a reference, and then we check if whatever is visible from the camera should if in mathematics it should not come in shadow. So that is the idea. Now, what is the problem here? Means we have seen the solution and we have seen the shadow acne, like if the texture and pixel density is not same and there is variation, then there is a light shadow, light shadow, light shadow, light shadow. This kind of pattern that we see, and generally it happens when light falls on a surface. So light falls on a surface. So surface normal and light, it has angle. In that case, that shadow acne grows. But anyway, means we have seen the remedy that when we do the mathematics from the shadow texture to the final pass, then we do some kind of offsetting, and then we are able to remove the shadow acne. So this is one story. Next story is that, as we talked about, so when we go for texturing, okay, so when we go for texturing, the area on which we mapping the texture, so that has four properties. One property is magnification, one property is minification. So magnification, minification is nothing but pixel and texture density kind of ratio. So that we saw in shadow acne. But next to that is minification and magnification. So that we have seen. Now, what about if texture and the plane on which texture is drawn, texture is small? Okay, so either we can go for so it's called a wrap S and wrap T. So STR is a kind of texel direction, as the way we have X, Y, Z. So if texture image is small and area to be drawn is big, then we can go for repeating or we can go for clamping. Okay. Now, as I said, that opengl is a if we have to think step by step. So, generally, what we have seen in the example, that we use the same frame, same projection matrix. So, the analogy of the camera that comes in the opengl. So, there we have model that is kept at the center, and then model is transformed with the model view matrix, and then again it is transformed through the projection matrix. Okay, and at the end we get the window coordinate where each pixel in the model would get drawn. So model is at center, then it goes here and then rotated, and finally it's come to a location, and then Mr. Projection comes into the picture and it does the clipping. Okay, so means in mathematics there is nothing called clipping. It goes for matrix multiplication, and then it cuts what doesn't come in the clipping. So even though we take the projection matrix same as a texture generation and what we see from the camera, so first pass and the final pass, even we take the same projection matrix, it's still model view matrix matters. Means they are different. So if model view matrix for the shadow pass and camera pass, final pass, if they are different, then the shadow texture, what we generate, so that texture, the width and height will be different, because we are using projection matrix, and especially if we are using perspective. So in that sense, it will be different. If it is different, then from the camera, from the final pass, whatever the area on which we are drawing the image, that area may be bigger. If that is bigger and texture is small, then it will come to wrap S and wrap T. So if I set the clampage in wrap S and wrap T, it will stretch. Texture is small. Area on board on which it will draw, it is big, or it has many items. Texture is small. Then it will have stretching, because it has to stretch to fit into the board, right? And if we don't go for a clampage, we'll go for repetition, then it would repeat. Shadow will get repeated. I have seen on kind of internet that there are lots of algorithms are coming. Our model view matrix, the camera model view matrix, even though we are taking projection matrix same, since model view matrix of the camera and light are different, so the window, the way it sees are different. So clipping happens and both are different. So in that way, it is different. So how we can make similar so that there should not be kind of stretching or clamping or repetition. Okay, but we'll see a way that is very different, and how we can kind of remove the kind of this unknown, unlikely clamping or unlikely repetition. Okay, so that procedure hangs in texture unit. Okay, so OpenGL works in a fashion that if I have an image, then image will get status of object. Okay, so image is nothing but it's just byte data that will get a status. Please refer kind of texture tutorial. So that will get kind of status of texture object. So now, since it is a texture object, it will have a data as the image data, and it will have operations. So operations like mag min, wrap s, wrap t, and for the anti-aliasing and these kind of things for other factors. So we can have operations. So texture object comes into the picture. Then after texture object, there is another guy comes into the picture. That is called texture unit. Texture unit and texture object, they work together. So what we want means, if I have a set of pixels in the kind of board on which it has to draw, and if I have a texture, it has set of texture, then each pixel will get what color from the texture. That is the final question. Means I won't go for this much kind of discussion, but discussion is based upon it. So if I have a set of pixels, each pixel coloring is simple if I take from the interpolation of the vertex or interpolation of the vertex from the lighting. But what about each pixel color has to come from a texture or set of texture in the blending? Yes, becomes heck. So in that way, OpenGL goes for, even though it is a C function, but it goes for object oriented, and it comes with the two entity called texture unit and texture object. So we say, this is my pixel position. Mr. Texture Unit, can you tell me what is the texture color? Now texture unit, as we see in the shader programming, we say sampler 2D. So that is the texture unit. So texture unit takes the pixel position, and then after that it goes to texture object and say, this is the pixel position. So can you tell me what are the operations you have? For wrap s, wrap t, or minification, magnification, and then for kind of anti-aliasing and for MIP mapping. So for all those stuff, what functions you have? It uses texture object functions and data, and then it thinks about the actual texture color. Okay, there is means if we go for repetition, okay, then image is getting repeated in the final shader program, and then since we are looking at the near and far when we draw the shadowing, so we go for multiple shadow. That is completely unacceptable, undesirable. So in that sense, we kind of we get the so when we go for final pass, we have pixel, okay, and we have interpolated texture that we in final pass we again generate the texture from the lighting source. This is what we have seen. From the initial pass, from the lighting source, considering it as camera, then we draw the texture. Then in final pass, there are two cameras. One lighting camera again comes into the picture. From there, we go for texture and then interpolated textures. So there, if texture crosses the image boundary, then in that scenario, we generate kind of mathematics that it should not draw the texture. It should not draw the shadow. Okay, so I have a texture. It has to be drawn on a board, and here is a light. Light falls on the texture, and there is a repetition of the shadowing, because texture has to be repeated, because the opengl, the camera vertices are more. I mean, pixels are more. So texture has to be repeated. So if it has to be repeated, I mean, shadowing has to be repeated. In that case, we try to find out what are the area that is away from the texture, means beyond the boundary of the texture. If we are able to find that, then we are not going for shadowing mathematics. Means, boss, please draw it. I don't want shadow. Otherwise, go for shadowing. Otherwise, it was going for shadowing for other areas beyond the frame, and clamping or repetition happens. So let's not go with whatever is kind of we see on the net. So we go with the simple fundamentals, and we can remove these kind of unwanted things that anyway we are getting through the texture unit and texture object. So repetition in the shadowing or clamping in the shadowing. So that means, okay, and we are receiving kind of questions like what app or what software we are using to draw the kind of whatever we are seeing, and in future, like we have promised that drawing will be minute, and later in the future we will kind of attach it to machine learning or artificial intelligence engine, so that we can see more enthusiasm and kind of more generic graphics in social terms also. We will have kind of real life example. Okay, so what app or what software are you using? We are not using any app, and we are not using any software. Okay, so we are using one small, very small Python program, and that is generated locally, and it is not generated internationally. So it is very local. Like we see localization and internationalization techniques when we go for kind of multi-language supporting. So there is no internalization, so it's a local code, and it's a very hardly 3 or 4 functions are there. One is for display and one for handling the keyboard. That's it. And then we see that how it works, that we have seen. So that small program